Okay, so next we're going to talk about means and two-sample problems, okay? We have two different types, two different ways that we can set up our experiments or observational studies or whatever that come into play when we are dealing with means, whether a confidence interval or hypothesis test. Okay, and it's important to be able to recognize the difference, and we're going to do that through writing alternate nulls for several different examples. Okay, so we have two different ways to set up our experiments or set up our studies. One, we can have two completely independent groups. These could be the same size, we could be different sizes, but the thing is that they are not linked to each other like you have with randomly assigned treatment groups in an experiment. Okay, so that's option one. Option two, we have two dependent matched pairs or matched samples. When you have two dependent or matched samples, some way or another the two samples are related to each other. Often this will be two sets of measurements on the same people, like a before and after. It might be twins who are, literally related. It might be other sorts of relations like husband and wife pairs. Okay. So if you have two samples that are independent, right, we are going to use what's called the two-sample T procedures. And we're not going to talk about the formulas just yet. We'll get to those. But how we set up the problem is different. So we need to focus on what we are estimating and what we're testing, how we're going to write our null and alternate. So our two independent samples that are dealing with means are going to look a lot like our two proportions problems, right? We are estimating the difference between our population means. So we're estimating, if we're doing a confidence interval, we're estimating mu1 minus mu2. If we're doing a hypothesis test, we're seeing, are the two population means equal to each other? Or is one bigger or is one smaller, right? So the clues or the cues that you have two independent samples are things like your samples are two different sizes. That's a dead giveaway that you have independent samples, okay? Because if they're not the same size, there's no way that an individual, let's say in one sample, let's say we've got group A, we've got group B, and let's say we've got Mary in this group. If they're independent, then that means she doesn't have any real connection to anybody in the other group, right? They're completely independent. So there's a lack of any sort of link between people or subjects in the two groups. There's two randomly assigned treatment groups, things like that. So we'll talk about the formulas later, but this is the new stuff. This is the things that you have to be able to figure out. So the alternative is you might have two dependent samples, right? If the samples are dependent, we're going to use what are called matched pairs procedures. And in this case, this is basically saying, hey, I've got two sets of people, like down here in this little picture down here, it said paired designs. And so we've got purple guy, green guy, orange guy, blue guy, so on and so forth. And I'm guessing this is something with like toothbrushing and stuff, right? And so we've got a measurement with them using the regular toothpaste, and then we've got a measurement with them using maybe the tartar control toothpaste, and we're seeing which one does a better job, right? And so in this case, so two sets of measurements on the same people, you've got one set of data being all the tartar. Oops, I noticed that they weren't all tartar. And the other set of data being all the regular. And there is a link between those two data sets in that you have the same person in each group, right? And so we could think about, like, let's say I was talking about, I've got this magic test taking pill. No side effects, helps your test scores, right? And so I could say, okay, I've got all you guys, you've all agreed to be in the experiment, and we're going to do random assignment. There's the placebo group. There's the magic test taking pill. And there's random assignment to the two groups. And so these would be two independent samples. And if we wanted to compare test scores, let's say test 3, we would say, hey, I'm going to set up my null, and I'm going to say, you know, the mean test score for the placebo group, that the magic test taking pill doesn't have any effect, and therefore the mean for the magic test taking pill group on their test 3 versus the placebo, that they're the same, right? That would be my null. My alternate, I'm going to have it look exactly the same. I'm going to have to erase that box there, make it a little smaller. And of course, we hope the magic test taking pill works and increases your test scores, right? So their mean would be higher, and so the alligator eats the bigger number, right? So it's going to open up to the magic test taking pill mean. So that would be a 2-sample hypothesis test, okay? But I could have designed my experiment a little bit differently. I could have done a matched pairs. And in that case, maybe I would say, hey, I'm just going to make up some names, right? I got Mary, I've got John, I've got Michaela, whatever, right? And they are randomly assigned to either take the placebo or the magic test taking pill on, say, test 2, and then on test 3, and we compare there, right? So let's say, so we got magic test taking pill, we've got placebo, and so let's say Mary makes a 90 on the test where she has the magic test taking pill, and she makes an 80 on the placebo, and John here makes a 95 with the magic test taking pill and a 75 with the placebo, and Michaela makes an 85 with the magic test taking pill, but a 94 with the placebo. So here, these are dependent samples, right? Because Mary took 2 tests, right? She's got the magic test taking pill score and the placebo score. So those are related because they're the same person, right? If I pick the 80 out of the placebo group, it's linked to the 90 in the magic test taking pill. So what we do in this case is we're going to turn a 2-sample problem into a 1-sample problem by calculating D. This is the difference, one data value minus the other, and we're going to do that for each individual in the data set. So we're going to say magic test taking pill minus the placebo. So 90 minus 80, her difference would be 10. John's 95 minus 75, his difference would be 20. Michaela's 85 minus 94, her difference would be negative 9, right? And so here, now, when we do our hypothesis test or our confidence interval, we're not dealing with the original data anymore. We're going to be dealing with this new variable, the difference, okay, which is why we call it D. And so we will be estimating or testing, depending on if you're doing confidence interval or hypothesis test, the mean difference, which we're going to call mu sub D. And it's going to be important that you define that. So that's going to be the mean, and I'm going to say this, magic test taking pill minus placebo. So that kind of subscript there indicates, hey, this is a difference, and it tells you what order it is, right? Or sometimes you'll say mu sub D, and you'll define where D is magic test taking pill minus placebo. Whatever, it's fine. So your cues that you have a dependent sample situation is if you have before and after measurements of the same individuals, so you've got 2 sets of measurements of the same individuals, or you have twins or other closely matched individuals. Okay, so that's it for this one, and we're going to do some examples, and that's going to be it for now.